Hello everybody, hope you guys are doing well. So continuing on our journey in networking, today we will be understanding the TCP/IP stack, and yeah. So basically, we had uh, um, like we understood the different layers in the TCP stack. Um, so now we would be starting with what do you say, network and transport layer, and then oh, what has happened? Let me go. Something has changed, so let's okay. Is this oh, and then okay, let's, I don't know why it's not detecting that, but let's make sure. Just give me a minute. No, let's delete this thing. And then okay, so perfect. You are studying the TCP IP stack, right? TCP IP. The OSI is the theoretical model, right? OSI is basically the theoretical model. Uh, there are 7 layers in the theoretical one, right? However, in TCP IP, we only have 4 layers. This is the much practical model that we have, or this is how the internet works. So there is so if this is my sender and receiver, right? So I'm on the center side. Let's have this thing drawn here. So if I'm on the center side, then I have a this is my sender. Okay, this is my I don't know what is happening, but why is it doing this? Just let me, I don't know, did I press something or something? Oh yeah. So now we are on the center side, and then we have the receiver and as well, right? So we're on the center side. The first layer that we are is basically my application layer. Then I have network layer. Then I have transport. Then I have my data link layer. So on the receiver end, the receiver will start from the and then this is the physical connection, right? Physical slash virtual, however. This is the physical medium through which the data is being sent. Then I have the data link layer at the receiver end. Then I have the transport layer. Then I have the network. And then I have application layer at the top. So on the central side, it is going to work from the bottom, and we are going to go all the way to the top. Okay, so from the central side, it is working from top to bottom. Now, okay. So now we have already studied. We already saw. We saw data link layer. Then we have seen the application layer. So now what we are going to see is the two most important layers, the transport and the network layers. Now these are the most important layers in which the actual connection is going to be established. Now data link layer is basically for error correction. This layer is mainly for error correction and then identifying device, right? Like for example, you have Mac. Mac protocol is media access to identify which device in the network is accessing the data. That job is done at the network layer, right? What I can do is I can shift this thing maybe a little bit. Let's have this thing. No, does this? I'm trying to arrange this thing so that. Oh, yeah. Let's try to fit this to our frame so that. And now let's expand it on one end. And then let's move this thing on the. This is some. Let's delete the other captures we have. If you need, we will add them. Is it correct now? Or it has to be this thing. And then I think so it is this line that we need to. Or is it fitting this? So from here, so if I go and type, this thing has. Oh, yeah, from here to. Okay. Yeah, so as I said, basically we were dealing with physical layer, right? So basically, oh yeah, we had seen some other layers. Um, so data link layer's job was basically to have error control and MAC protocol. So MAC basically stands for media access, right? So this is media access protocol. So this is for identifying the specific device in our network. That means if this is our modem, right? This is the modem, or the, in other words, we call this as the gateway, right? And then you will be having different devices to connect it to this. This can be an iPhone or an iPad or anything else. So what is going to happen is, I see it's checking from the bottom. Let's fit it to this end so that fit it to this end. Yeah, so this is basically my iPad and my. Then you might have other devices, for example, Google Doodle. So all of these devices are going to work on the internet, right? Now we need a mechanism by which we can identify which specific device are we targeting. So that is done by the media access control protocol. Now, so hence the data link layer is basically for error control. This it's also called as error control layer, where you do most of the error checking. Application layer is basically so the app, and then you have framing and other functions as well. Oh, this is responsible for node to node communication. Yeah, we are doing node to node communication here. This is basically my node to node. So node to node communication happens in this layer. Now the next layer below it is the physical, right? So then we at the application side, we are having the application layer, right? So this application layer is basically responsible for working at the application, right? So it is responsible for sending out request, because we are working on www, right? So we need an www mandates and HTML sharing, right? On a hypertext sharing, so that is going to happen at the application layer. Now the network and transport layer. So let's see the role of network and transport layer. So this okay. The network and the transport layer is basically where we are going to do end-to-end delivery. So network layer job is basically to do the end-to-end delivery. So network layer is end-to-end delivery. So we have end-to-end delivery over here. Now when we mean by delivery, basically we are going to do some so for example, if I have a mail, right? So I need the sender's address, and then I need the receiving entity's address as well, right? This is my senders. Okay, let's. So I need the senders and this is my sender, and then I need both the sender and the receiver's address. So this is the first thing. So end-to-end delivery will first include addressing. So you need the address, right? Now then second do is basically which path to take. So we would be doing routing. Routing basically indicates uh, which path today. Now we'll see yeah, so for now let's go a little bit further in addressing, and then we'll do some sort of we'll see the congestion there are other protocols as well. We'll see that later on, but this is the major responsibility or the major job that we are going to deal. The next thing that we have is basically something called as so first let's see addressing, right? So addressing, when we'll see the IPv4 address, and then the newest one that we have is basically IPv6 addresses. Then when we are talking about routing, there is static and dynamic. So we will see both of them. So we will see static and dynamic. Now, apart from these protocols, we will try to understand why do we need congestion control at where. So there is some error handling mechanisms as well. So to error handle at this layer, we would be having congestion control. So for error handling, this is basically congestion control. So okay, let's yeah, for error handling we are going to do congestion control. We'll see what and why the error occurs. First we need to identify what is the issue there, and then we need to make sure that we are taking care of the congestion control there. Now after learning about transport layer, we will be moving on to the transport layer, right? Now we are going to the transport layer. The transport layer is the person that is responsible for establishing the connection. So when we are at transport layer, basically we are making communication being established here. So transport layer, this is the fourth layer. So this is my transport. So at transport layer, we'd be doing what do you say, end-to-end communication. Even this is end-to-end, but then this is so that was just delivery. Here we are going to do end-to-end communication, and we'll see with an example how and when what protocols are going to be work and how they are going to work. Or it can also say application to, this can also be called as an application to application delivery. So you can say application to application. So here is something when we introduce the concept of something called as port numbers. We'll see what these ports are and why do we need them. Most common protocols at this layer that we have is the TCP/IP, or the most, and okay, the protocols are responsible for doing this. So protocols for end to end, application to application. Uh, First is going to be my TCP. Then we'll see three-way handshaking here. We'll also see something called as secure shell or SSL connection. And why do we need that? Then we'll see something called as UDP. Okay, now let's go back to Frozen and see. Now we are at network. So let's transport. Okay, network layer and logical addressing. Now, as we discussed, now for this level of communication, we are going to use a global scheme. Okay. Now let's go to network layer and see IPv4. Now let's start with IPv4 addresses. Now we'll see supernetting and subnetting as well. So we'll see that also. Let's go to IPv4. Now IPv4 is basically a 32-bit unique and universally defines the connection for a device to that internet. So basically IPv4 is a 32-bit long. So first point is it is going to be 32 bits, right? So it is 32 bits long. Then these are unique. So the next point that we have is unique addresses. Then they are unique in that sense that each address defines one and one only connection to the internet. Two devices will never have the same address at the time. We'll see that later by using some strategies. How address may be assigned to a device for a period of time and then taken away and then assigned. So we'll see how address, because these are limited, right? Limited in nature, and we'll see how to reuse these addresses. On the other hand, if a device operating at the network layer has some connections to the internet, it needs to have. Okay, we'll see that how a router is going to work. We'll see that the address space. A protocol such as IPv4 defines the address space, and address space is the total number of addresses. If a protocol uses n bits, then the address space is 2 power n because it's okay. Now here I'm having 32 bits. That means total how many addresses can be possible. So now computer can only accept as okay. Computer or any electronic device will either accept a 0 or it will take in a 1, right? Or we can have 1. Now let's see the address space. So how many addresses do we have in total? So in total 2 power 32 means we have around okay, this is we have around these many addresses in total. So you're at 10,000, 10,000 lakhs, 10 lakhs crore. Okay, so we have around 1 billion, I guess. This is, oh sorry, 4 billion addresses. Yeah. Now, okay, now there are two prevalent notations to show an IPv4. One is binary notation, now, and the other is a decimal notation. So how do we write these addresses? So there are two ways to do this. So write IP. So first is basically using decimal, and then second method is basically to use dotted decimal. So first is basically dotted decimal. This can be called as dotted decimal, and the second one that we have is basically something called as a binary notation. Binary notation. So if I have 32, that means if I group it in 4, the total, so 32 grouped in pieces of 4 can be 8, right? So I'll have so this is 4 times 8, right? So what I'll be doing is I'll be having 4 groups of 8 bits. So 1 2 3 4 5 6 7 8. 1 2 3, and then so 2 more we need, right? So 1 2 3 4 5 6 7 8 again. 2 3 1 2 3 4 5 6 7 8. Then again we have 1 2 3 4 5 6 7 8. So in total this is going to be 32, right? So I have 8. Oh sorry, I have 8 8 8 8. So that is 4 times 8. That is 32. Now to do decimal is basically you need to do this conversion into decimal, right? Now for that we need to know how to convert okay, so the way, so each of them will be representing a decimal. So if you do a decimal conversion of this, this is like I'm assuming that this is like this is some number, right? So this is some number. Like this may not be the exact binary to decimal. It is, I'm just trying to say, like this can be so when you convert this, now this may not be the exact conversion, just for the sake of exact, and then you have one more coming from it. So you put in dots separated by them, and then you have 149, and then you have okay, then you have one more here separated by dot. So you do a separation by dot, and then add in the number here. Then again what you do is you add in a dot and do separation. Okay, and then say this is 2. So this is how it is going to be represented in decimal. or the dotted notations, dotted decimal notation. This is how it is going to be represented. Now okay, so now now there is something called as classes, right? So why did we classify address? Now what we did is we classified these addresses into two types. We sent IPv4 addresses. So we have IPv4. We said let's classify into two types. So one is basically my class full, where you have different classes, and then other was classless, where we don't have a class, right? And we haven't okay. Where did yeah. Now in IPv4, at its inception, we use the concept of classes. When we say the concept of classes, then we say this is class one. Now this scheming become obsolete. We briefly discuss it here to show the rationale or the thinking behind the class. In classful addressing, the address space is divided into 5 classes. We can find the class of an address when given the address in binary notation. If the address is given a binary notation, the first two bits can immediately tell us the class of the address. If the address of is given in a decimal dotted notation, then the first byte can identify the class. Now both methods are shown. So basically, what we did is we kind of divided our addresses into different classes. We'll see. Okay. So there were certain rules that we did. Okay. Now we do. So first see is how we organized our addresses into classes. So this is organizing addresses in classes. So first is we have class A. Now class A first the first byte is, if the first byte is 0, then we say it's a class A address. Then we have class B. If the first byte, if you have a, if the starting is 10, then we say it's class B. Then we came to class C. So in class C it is 110. If the first byte is 110, so we kept on adding this 110. Then we say it is class C. In class D, if in the first byte we have 110, then it is class D. Then in class E, if the first byte is 111, then we say it, or 4 times 1, then we say it is class E. Okay. Now we can find the class of an address when given the address, and yeah, so you can, using this you can find the range, right? What will be the range of my first byte? So using this you can find the range could be found out, right? The starting and the ending could be decided. There are two fundamental more concepts that we need to understand. Wait, let me So we are doing class full, right? Okay, now let's see classful and classless IP addressing. Okay. Now, why did we have why did we do class? Why did we divide it into classes? Okay, let's see. So now we saw the different classes. Let's see why do we have them in the first place itself. Now we divided now in 1980s the internet was small and mass. So initially this internet project was started by ARPANET, right? So this is basically it was this was during World War. Okay, let's write this thing properly. So this was during World War era when we needed to share information between universities, right? So then we developed something called as ARPANET. This was done by US military itself. This was the first net that was internet that was made. Later on, we moved to something called as INA, right, or IANA, which is basically the central company or the organization that manages the addresses, right? Now, why do so? Now the IP addresses were limited, right? So, assigning all IP addresses to an organization was not correct, right? So what we did is basically to manage the IP addresses so that more and more service providers have an access to IP. What we did is basically based on the organization size. So based on organization size, we divided the IP address. So we divided the so based on how big our organization size is, we divided the IP addresses uh, into some commonly used blocks, right? So in some most commonly used classes, right? Now, by defining this, what we did is we allowed predefined IP block sizes, and then what has done is it was very easy for administration routers to determine which network or which host portion is not working properly, and INA could easily assign to a class organization. Okay, now let's see like how is this all happening? Like, why do we need the addresses first? The first is basically we need. Okay, why do we need IP addresses? Uh, First, let's understand what's the core need or what is the problem that we are trying to solve. Now if you see internet, right? So internet is basically internet is internet networking of computers, right? So you have a group of computers. So for example, this is one country. So this is USA, and then you have other computers in other countries. So you have, so for example, this is in Canada, right? Now these are two different countries, right? But they are on the same continent, but this is two different countries, right? So what if the our computer from Canada needs to or our computer from USA needs to access data um, to a computer that is in Canada, right? There should be, it will go through a series of a network, right? I mean, it's not like this is a straight connection, right? There will be a different number of connections. That means it might go to this computer. From there, it might go to some other place, may go here, and then it might reach. So it is not that just by identifying you're directly sending the data as a link, right? You're going to go through a number of paths and series. Now what IP address is going to do is, so IP address is basically going to help us to identify which network between which network has the communication, because it's going through a series of computers, right? Now each computer will be connected to its own network, right? Like its own local area network. For example, uh, we have different internet service providers, right? For example, in India you have Geo, you have Airtel, and then in US one of the famous is AT&T, that also is an ISP provider. In Canada you have Rogers, you have Bell, you have Telus. Now each of these companies is going to provide you a modem, right? So you have a modem here. So this is my modem, right? So this is like a the so then I'll be having different modems. So I'll be having different modems. So suppose this is my at Geo modem. This is my Airtel modem, and then you have another modem. So you have Rogers present over here. You have Rogers. This is even Roger will give you its a modem, right? This modem is basically the access to the local devices, right? So this may have a number of devices connected to it. This may again have a number of devices, and this may also have a number of devices connected. So what if our device one wants to communicate to a device two? Then it will go through a series of connections, right? But the packet. So this is, suppose this is my packet that is I'm going to send. This is going to send a packet. But then will all these networks connected through and I need to send this to a person who is living here. how is this packet? So you are having different networks, right? You may have others. So now you have one more network in BSNL has also come up, right? So BSNL also is providing network. Is an ISP, right? But it's a government owned ISP. This is BSNL modem. Yeah, BSNL. Now what is going to happen is the geo packet will have to travel through a series of networks, right? To first let's look now first let's not talk about inter country. Let's talk about within the same. So for example, what if a person from geo wants to contact a person who is using, so this is my endpoint, right? So let's say this. So what is going to happen is, so all of these networks need to be connected to each other, right? So there is something called as an internet exchange point. So you have an internet you have an am I signed in? Yeah, so what would we would be having is, suppose I need okay, so a person from who is having a geo modem wants to communicate to a person who is having a what do you say uh, Airtel modem. So what these companies do is they sign something called, they are all are going to meet with each other inside an internet exchange point. Just as you have telephonic exchange, same you have on similar lines. There is something called as internet exchange points. So this is, so basically I need to enter. So at this point I'll be deciding, or this at IXP I'll be deciding which area, which ISP network I have to enter. So this is basically deciding which ISP network have I to enter. At this level, I'm going to decide that. Now let's see how it is going to happen internationally, right? So let's see how it's going to happen internationally. So let's. This is still in a single country. This is very much understood, right? They sign certain contracts over here. Certain contracts have been signed. An example, how much will be the charges when you are doing this exchange? What is the contract policies, like how much roaming should I charge a roaming fee or not, or should I allow my free travel, or should I put a limitation on data to enter? So all of these is determined by these contracts, right? Now let's come to something when we want to do a country to country transfer, right? Okay, so now what we are going to do is, so this is my country to country. So here I have my geo. So I am this is my India, and then I have another country. So say I'm going to go to AT&T. So AT&T, and then I am in USA. So again, data will first come at the internet exchange points. Now, and once it identifies that we need to send it to a different country, these countries are connected each by each other via something called as a fiber optic cable. These are underwater, undersea cables. So once I come to this and identify that this is a an international call or an international thing, and then I'm going to send it to my cables. These are fiber cables, and then these are going to route it through, and then I'm going to go to the local IXP present here. This is my local IXP in USA, which is going to set which ISP network should I enter. Okay, so this is how data is going to be routed in one country from another, right? This is how the path it's going to take. Now within a network, it's very easy, right? So because um like within the same network, it shouldn't be that difficult, right? Now how am I going to identify whether uh, which network am I entering? Whether like this geo, how am I going to so I'm the criteria that I'm going to use is basically I'm going to use IP addressing here. So IP address is what is going to tell me where to send my data, how should I route it, and what is the end destination. So hence whenever we are talking about addressing, we are talking about the end to end data transfer, that means from the sender to the receiver end. Now okay, now so we conclude that to facilitate data transfer we need some of sort of address mechanisms and to be given to my ISP, which is going to enable me to access, right? Now how that um like how much address should I give to an ISP, that is what is determined by uh something called as classful, right? That like in previously we had the classful, right? So we were using that what do you say, that classful behavior to allocate IP, how much addresses should be allocated to a single ISP. Now, since there is so each yeah, so as I was saying, to uniquely identify the networks, we need something called as an IP addressing, right? Now, who allocates these IP addresses? There needs to be somebody that allocates these addresses to our networks, right? So the way that we allocate IP addresses is or the way the allocation of the IP address is going to happen is there are public global authorities, right? Uh, so who that do this allocation. So first is basically we have something called as okay. Just let me check if there is any effect on the stream. Okay. We have something called as an IANA, right? So this is basically top level, right? This is at the topmost level. In the topmost level, we have this organization called as IANA. Now, this delegates the block of so this it is going to allocate the IP addresses to local or to say to regional internet service so regional internet registries. I have something called as regional internet registries. Okay. So then we come. So this is at global level. For example, at global, when we say is the entire Earth, right? That's like a global thing. So we are at the global level. The global level is done uh, by IANA. So what it does is IANA addresses or allocates the IP address to regional levels, regional ISPs. Something change. Let's Okay, just give me 1 minute. Did it disconnect or something? Can just give me 1 minute. I guess it has got disconnected. Let me. Okay. Yeah. So as I said, uh this IP address is allocated to the so INA is at the global level, right? Then it allocates the IP to the regional address to my regions, right? So I have to regional organizations. For example, you have regional internet registry. So these are basically regional internet registries. There are different regions. For example, so continent-wise, we have been divided, right? So first is basically Erin, that is for Northern America. Then you have, okay, this is North America. For example, Canada and other countries. Then we are in something called as RIPE. So this is the Middle East, Europe. So this is comprising of three things. One is Europe, Middle East, and Central Asia. So you have, then we have Asia Pacific. So that is done by that is this is for Asia and Asia Pacific. For example, China and other countries in Asia, the Asian continent basically. Then we have something called as Afrinic. I have that is basically Africa, and then I have Lacnic. This is Latin America, Central and Caribbean. So then from these regional ISPs, or for example, from these regional organizations, so from regional organizations, I'm going to connect to my local ISPs. I have local ISP. So each ISP uh, is being allocated a certain set of IP addresses, right? So local ISP allocated. Now in so if I am in Asia, let's this so in my Asia, in specifically if you speak about India, we have Geo, BSNL. So these are all going to take IP addresses. Yeah, so money is paid, right? For each addresses, you need to pay certain amount of money. Then, then for example, if you go to Northern America, you have local ISPs. For example, you have now when this is all you have Bell, then you have Telus, then you have Rogers. So this is how the IP allocation is going to take place, right? Oh, I forgot that. Yeah, for each IP allocation, so this is basically how in my Asian subcontinent, these are basically the regional registries, right? So you have Erin, that is in Northern America, then RIPE you have in Europe, Middle East, APNIC you have in Asia and Pacific, then you have Afrinic, so this is the African continent, then you have LACNIC, it's Latin America or Caribbean Islands. Then these regional ISPs are going to contact the local ISPs are going to contact these regional organizations, and then you're going to get this. Each company is going to get its own IP set of IP address, right? The set of IP address is basically going to identify this for identification which network am I entering, like which basically for identifying networks. So hence we need to for the identification purpose itself. Hence we need something called as uh, IP address, right? So the goal of IP address is basically to identify from which network to which network am I sending my data. So I'm going to say from which to which network am I sending data? For this purpose, so based on the sizes, based on how big the ISPs is, we will define, or we kind of grouped in them into different classes based on their need. If you need a bigger IP address range, you need to take a bigger class addresses, and so on and so forth. So for each IP address you take, if for a set of IP address you take, you need to pay money, right? So basically it's costly, right? It's costing you some money. um so each block is basically going to be that it's going to cost money, right? So if you have a person from your company, or if you have some tie-ups in that, for example, if you have a person who is in this organization who can, for example, if you have someone who is in my regional IP allocator, if you have, if he's supporting your network, then he may reduce the price or he may increase the price. That is um, how it's going to work. So I guess yeah, that is all a brief introduction about IP networks. Basically, it's for identifying networks. Um, so yeah, that's all for this session. I hope you guys liked it. Please subscribe to my channel, and I'll see you in the next one where we actually identify the blocks in a, so in earlier times we were doing this block allocation. Now we have moved to classless. We'll see why we moved to from class 1 to classless. We'll see everything. So yeah, that's all for the session. I hope you guys liked it. See you in the next one. Till that time, take care. Bye bye.